Hello everyone. So this is my second video for chapter 10. I'm going to walk you through some of the questions here, mainly the ones that most of them will deal with stack crunch applications, though not all of them. I do want to um, show some of the questions that can be a little tricky as well. So I decided to start with section 10.1, question 4. I'm going to leave the theory to you guys to look at the videos to assist you with. I'm going to focus on the stack crunch because I know the videos are going to be very helpful in that regard. So in this question is asking you to find the associated correlation coefficients with what's in the graph here. So let's looking at scatter plot 1. So here this is. Now, when we look at, let's say, the 5 scatter plots, you notice that these two appear to have kind of weak correlations. So we're expecting those to be closer to 0 than 1 or -1. But if you look at the comparison of, let's say, 1 and 5, that these both appear to have strong negative correlations, but this is going to be the stronger of the negative correlations. So we definitely want to find the correlation is going to be negative, and it's going to be fairly close to 1, and whatever the weaker of the two is, that's what our choice is going to be. So notice here that one is like negative 0.997, the other one is like -1. So I would say that for choice 1, it's going to be 0.997. Number 2, that's going to be, let's go with number 5. That's going to be -1. So we have those two choices done now. This one appears to be a pretty strong positive correlation. Not 1, but pretty close to it. So let's look at number 4. So I'm going to say it's probably going to be 0.997. So what we've got to decide between now is what is like -0.377, what's positive 0.377, which is going to be 2 and 3. So let's go ahead and take a look at 2 and 3. I would say if there was one that's going to be positive, this is the one that's more likely to be positive, and then this is the one that's more likely to be negative. So I'm going to say scalar 2 is positive 0.37, and then scalar plot is going to be -0.37. So let's go ahead and if we're done with that, let's check our answer. And huzzah, it is done. Let me see if I want to go to the next question or not. I'm going to ask questions. Okay, yeah. So for this one, we're doing hypothesis testing. The null is going to be p is equal to 0. Hold on. And this will be p is not equal to 0. This is something won't appear on your final exam. Okay, but that's always going to be the case with hypothesis testing. We're not going to do, if it wants to identify the correlation coefficient, that is up here. Let's see, the 3 decimal places, so 0.971. There you go. Okay. So, and critical values. So again, this is going to be 3 decimal places. It'll be 0.268. What are the two critical values? It says that this is a two-tailed. Hold on. Yeah, just only one side. So it's going to be two critical values at plus and minus 0.268. Okay, there you go. So I'm not gonna continue to beat this question up because p-value two-tailed at 0 is sufficient to support the claim that there's a linear correlation. Yes, because the absolute value test statistic. Not sure what they. So looking for the test statistic on this one. Hold on. What did they say it is here? Oh well. Because they don't give us the test statistic. They give us that, but they do give us a p-value, but they don't give us the test statistic. So I wonder if the answer cannot be determined based on the information here. Let's see if that's the case. Yeah, that's right. It's gonna be this, but I don't know what the number this is gonna be. Let's see. Trying to think if they give us this here. B. Okay, so in this question, I'm just trying to see how this would be calculated. Since this is on the bottom, I'm not going to worry about this. I probably should just remove this question and not count it. Because I'm not seeing the information I would usually teach how this is calculated. So perhaps I will get some extra credit on these questions, so you don't have to worry about doing questions like this too much. Yes, I want to skip it. Okay. Use the given data set to complete parts A through C below. So what we're gonna do now is we want to get a scatter plot of this. So what we're gonna do is we're gonna click on StatCrunch. And let me share the StatCrunch page now. Okay, and we want to graph. I'm going to graph this as a scatter plot. I'm hoping everyone can see this here. I think you can. Okay, and you should see the values of this here. Looks like you're still looking at this, so it's going to look like choice B for the graph. So I'm going to go back and share that page. So it should be choice B. All right. So let's find the linear correlation coefficient of R. And determine whether there is sufficient evidence to support the claim of linear correlation. Okay. So now for this data, we're going to find the linear correlation coefficient. Now, if you look at this will definitely appear to be nonlinear. But sometimes, just depending on the shape, it may still be determined that a linear correlation does exist. So we're going to go back to StatCrunch to see how we do that now. And we'll go back to stats. Let's see. Not goodness fit. Regression, simple linear. Okay, let me go back again in case you didn't get that. So stat, regression, simple linear. Okay, stat, regression, simple linear. The x variable is going to be in x, y variable is going to be in y. And let's see, we want to, let's see. I think all this is going to be calculated here. I think it's going to get us, let's see. And it should have a graphical line on the next page. There it is. Okay, so there's the line. And let's see. Take a look at what we have up here. Here's the graph, or here's the equation of the line of best fit. Here's also the correlation of coefficient 0.817. Okay, so the correlation coefficient would be 0.817. You'll see it has the test, this gives the test statistic as well as the p-value. And you'll notice here that because it wants us to establish if there was a linear correlation, the claim of linear correlation. Because the p-value is going to be 0.02, there's definite evidence of and then the p-value down here of the slope of 0.0021, there's definite evidence that there's a significant linear correlation. So let's go back to the problem. There you go. So the correlation coefficient, as we showed on a previous page, is 0.817. It says using the linear correlation coefficient found in the previous to determine whether there was sufficient evidence to support the claim of a linear correlation. Okay. And want to say there is sufficient evidence to support the claim of a linear correlation between the two variables. There we go. Okay. Let's see, part C. Identify the features of the data that would be missed if part B was completed without constructing the scatter plot. Okay. So the scatter plot reveals a distinct pattern that is not a straight line pattern. That's to choice D. At least I believe so. Because even though it fits a linear plot, the it appears to have a pattern of a linear plot. You can see from the scatter plot that it's definitely a much stronger nonlinear one. All right, let's see. We go to the next question now. Okay. This one again is going to be done similarly, so I won't bother to do that again. That'll be just additional practice for you. Let's see here. Hold on. So when I ask here, do the data points appear to have a strong linear correlation? I would say yes. Now, let's go. Yeah, so I would just say yes. Kind of, because what happens is, if there was just all these, then maybe not, because then you could go any way with it. But because of this, it makes it like a strong negative. I'm gonna go with yes and see what this says. You may not like it. There you go. What is the value of the correlation coefficient for all 10 points? Okay, so for that, we probably want to go to StatCrunch for this. Let's see, am I able to bring this up here now? Let's see, quick review. Oh, let's see. Now, in this one, it doesn't appear that StatCrunch, it's an importable to StatCrunch. So what you may have to do in StatCrunch then is manually put these points in and then work with it that way. So which is paint. Oops, that's the table we referred to before, but we're not going to worry about that. So if I look at this, let me just kind of shows the larger. So this would be like 0.18, 19, 110. So we just kind of do this here. Fine. So what I'm gonna do is I'm gonna go to StatCrunch, I'm gonna manually put these points in. I don't think I'll put a question like this on your final. It'll be 0.181910 to 8, but 9, 10, 2, 2, 3, 3, 3. This will be 8, 9, 10. And then the last point will be 9, 1. So I put those in manually. And it wants to know the correlation coefficient. So I'm going to go to stat, regression, simple linear, X, Y. Now, if you don't label, like I did X and Y, you'll see bar 1 and bar 2 here. Let's compute. And there's our equation of the correlation coefficient is negative 0.893. Be careful of rounding. Okay, so there's our correlation coefficient. And a p-value is going to be 0.0005. That's really, really strong. So yes. Let's go back to the original screen. So the correlations there are going to be negative 0.893. Oops, hold on. When it takes a long time, it makes me worry. Is that it? That's it? Okay. Is there a lot of correlation? Yes. Use the level of significance 0.05. So as long as p is less than 0.05, then there's a significant correlation. So yes, because the correlation coefficient is in the critical region. So yeah, so because it's in the critical region, I'm gonna say yes to that. Okay, so that's how a question like that is handled. Continue. What else do you want to know? Oh, what is the correlation coefficient in the 0.91 is excluded? Ah, okay. So let's go back to StatCrunch now and see what that is. Okay, so I think we'll have a very different result on. So go stat, regression, simple linear, X, Y. Yeah, it's just 9 plus 0x. And the reason is because you draw any line that's going to be like this, like is on 9 plus 0x. So what actually happens is you have the line y equals 9, which is a horizontal line that goes to the center. That's one that's going to be closest. What's the correlation coefficient of this? It has a correlation coefficient of 0. Because basically you can draw like any number of lines to this. So it's not possible to draw a correlation with this because you draw any number of lines, it's all good pretty close to this. So, and I don't run around the 3 decimal places because it's just 0. Is there a linear correlation between x and y? No, it's not. Because it's not in the critical region. What do you conclude about the possible effect from a single pair of values? The effect from a single pair of values can change the conclusion. That's correct. Okay. Because just that one point being like down there causes a strong correlation. So we call that kind of point an outlier, which can definitely affect the answer a great deal. All right, let's maybe we'll do the next question, maybe we won't. Okay, we've done that. There you click StatCrunch to get the graph of it. Oh, this is the last problem, so why not? And I think we'll actually, I'm gonna go to 10.2. I'm gonna try to wrap up this video before noon. Okay, so let me just stop sharing here a minute. Okay, and let me go to section 10.2. And let's go to issue. All right. Okay, so different hotels and certain areas around was selected that has a slope of 125 and a y-intercept of negative 335. So remember, the y-intercept is going to go down here and the slope is going to go here. So this is going to be the y-intercept is going to be first negative 355, and then the slope's going to be 125. And that's what we're after. Oh, hold on. Yeah, I don't think this is going to be x hat, but let me just check to be sure. Okay, yeah. So what they're asking to check there is, this is y hat, not x hat, because you notice all the combinations are like that. That's the only difference between each one, but you choose A. Which does the symbol Y represent? It represents the expected price when the hotel's rating is 0. So that's what the Y value represents. Hold on. What? Okay. The symbol Y represents the average price of. Oh yeah. Hold on. Not the price increases. Oh yeah. Just the symbol Y represents the predicted value of the price. I think that's what they're after. Just the predicted value of the price. There you go. All right, that's it. So, and that prediction is going to change based on our value of x. And that was something I was showing on a previous page with the equation 2 plus 3x. All right. I want to try to get somewhere where you actually have to do some calculations. All right. Well, let's see. For 50 I'll take question 5. For 50 random selected speed dates, attractiveness ratings were rated by males on their female partners are recorded, along with the attractive rating of females by their male date partners. The ratings range from 1 to 10. The 50 paired yields x equals 6.4, y hat equals 5.9, r equals 0. Oh, that's not a strong correlation, which I expected. And okay, now see the p-value is 0.08. This is what I was saying I was talking about before. So the p-value is 0.08. That's not less than 0.05. Okay. So if that's the case, then when the p-value is greater than alpha, then the best prediction you can make for this is just going to be the mean. So it's just going to be 5.9. What? Hmm. Oh, I'm sorry, guys. They said to use a 10% significance level. This is the last detail I missed, which is unusual to ask. So because the level is 10 is 0.10 and our p-value is 0.086, then we can say there's a significant linear relationship. So we are going to use the formula that they calculated. So we're going to put 8 into that formula there. So my apologies about that. I kind of jumped the gun on that. So because the p-value is going to be less, p-value of 0.08 is going to be less than 0.10, we can use this formula. So it's going to be 0.310 times 8. So this is going to be negative 5.44 because I put the value of 8 into this equation. That's what I got. Hold on. Well, come on. Point 0.31 times 8. Correct. Oh, I forgot my negative. Oh, it's yeah, no, I meant to make it positive. I didn't round it to one decimal place. I had the right answer, but I forgot to round it to one decimal place. So that's what I did wrong. So guys, watch your rounding on this. Now, if you do that on the test, I'll be sure to give you most credit, but I'm trying to hurry through this and get this video done here. So okay. Now they give you the equation here, so that's gonna be done the same. But I want to find a question where we actually have to form the equation from the information. Yes, here we go. This is the kind of question I'm looking for. So use the given data to find the equation of the regression plot, examine the scatter plot. So what we're gonna do is we're gonna find that equation like we did before. We're gonna put this in the StatCrunch, and I'll show you how to do this here. Okay. So what we're gonna do now is we're gonna go to stat, regression, simple, linear. The x variable is going to be in x, the y variable is going to be in y. Click compute, and there's going to be our equation right there. Now it says it wants everything around 2 decimal places, so it's going to be y equals 2.501, 2.50. Okay, and then the second part is going to be 1.1. So let's go back to StatCrunch. 2.50, and it's going to be 1.1. Now notice here, it just says round to 2 decimal places as needed. Here I need to round, but here I do not. And it should acknowledge that. Okay. All right, now it says create a scatter plot. So what I can do now, if I go back to StatCrunch, if I just arrow over here, there's going to be my scatter plot. Now, the one I'm most closely looks like it's going to be choice B. So I'm going to go back to that one. It says identify a characteristic of the data that is ignored by the regression line. The data has a pattern. You can see that in the graph. That's not a straight line. It looks parabolic almost. Okay. Well, that's the kind of answer we're looking for there. Okay. So let's see. You have time for maybe one more question. Okay. This one, like I did the previous question, you just got to type in the information. Okay. Again, I'll show you one more example about how to find the regression line. Okay. So I'm in this data here. We're going to open it in StatCrunch. And I'll share that with you. Okay, so I want to find that. I'm going to go to stat, regression, simple linear. Okay, so now okay, let me make that a little bigger so we can kind of look at more stuff. I'm bringing it over here. So the chest size is the X and the weight's in the Y. chest size, weight. There's always going to be like XY here. And then we hit, come on, pick compute. And here's the equation. This is the Y. That's going to be 227.1 and then 11.9. So let's go back to here. Oh, it's going to be negative 227.1. Why are two negatives there? No. 1, then 11.9. And watch out for negatives on that little part. Pick answer. There we go. What is best predicted weight for a bear with a chest size of 50 inches? So if you happen to see it here, you don't go to that. You're going to put it into this equation here. So it'll be 11.9 times 50, which is going to be 90. Hold on, no. 11.9 times 50, which is equal to 595. And then we're going to subtract 227.1. And that's going to be 367.9 pounds. But round to the nearest round to the nearest one decimal. So 367.9. Check my answer. And there it is. Okay. So I think I'm gonna wrap this up because I've got another class online to work with. So I hope everyone finds this video to be helpful. And let me know if you have any questions about any of these problems here. Thanks.